Welcome to another video on IT and Automation Academy. Today, we're going to explain Scada in a super easy to understand way with the help of animation. If you're new to automation and want to understand what Scada is, this video is for you. So, what is Scada? Scada stands for Supervisory Control and Data Acquisition System. It's a system that helps monitor and control different processes, like oil and gas, power, and more. Before we dive in, let's understand two types of architectures, factory-centered and remote. Let's start with factory-centered Scada. In any process, you need instruments like control walls, transmitters, VFDs, and motors. These instruments collect data, which is crucial for making decisions. Now, imagine these instruments as sensors in our body. They collect data about temperature, pressure, and flow, just like how our body senses heat or pain. Now, this data goes to PLCs, which are like the brains of the operation. PLCs analyze the data and decide what actions to take. For example, if there is some changes required in process, PLCs send commands to final control elements like motors or valves to meet desired process requirements. So the PLC serves as the central processing unit of the Scada system. It receives data from field instruments, processes this data according to predefined logic and algorithms, and sends control commands to actuators and final control elements. PLCs are highly versatile and can be programmed to adapt to different industrial processes. Let's understand in super simple analogy. Let's imagine you're driving a car. In this scenario, imagine if your car could drive itself. The autopilot constantly checks the information from the dashboard and makes decisions based on that data. For example, if it detects that you're going too fast, it automatically adjusts the speed. When the autopilot decides that something needs to change, it sends commands to the steering wheel and brakes, final control elements, to adjust the car's direction and speed. Similarly, in a process, if the PLC decides that something needs to be adjusted, it sends commands to motors or valves to make those changes. So, just like how an autopilot guides a car safely to its destination, PLCs ensure that processes run smoothly and efficiently by monitoring and controlling various parameters based on the information provided by instruments. In PLC, you can't directly observe the ongoing processes or the temperature within them unless you establish a connection using your laptop or access it online. Alternatively, you can link it with an HMI, which stands for Human Machine Interface. As its name suggests, an HMI serves as the interface between humans and machines. Through the HMI, you can visualize the status and values of various processes in real time. Next is Engineering Workstation. This is a computer system used by engineers and system integrators to design, configure, and maintain the Scada system. It hosts software tools for developing Scada applications, designing graphical user interfaces, GUIs, and configuring communication protocols with field devices and PLCs. Now, what is OPC server? OPC, OLE for process control. Servers act as intermediaries between different industrial automation devices and Scada software. They enable seamless communication and data exchange between Scada systems and various devices, regardless of the manufacturer or communication protocol used. Let's talk about Historian. The Historian is a database system that stores historical data collected from the industrial process. It retains a record of process variables, alarms, events, and trends over time, allowing operators and engineers to analyze past performance, identify trends, and make informed decisions for process optimization and troubleshooting. Now, what is Operator Station? The Operator Stations provides a graphical interface for operators and engineers to interact with the Scada system. It displays real-time process data, trends, alarms, and control options in an intuitive format. Operators can monitor the status of equipment, acknowledge alarms, and make adjustments to the process parameters using the HMI. What function does the printer serve? Well, it simply prints. If you wish to generate graphical trends or any other form of printouts, you can utilize this printer device to produce the desired outputs. Networking infrastructure. The networking infrastructure comprises switches, routers, and communication protocols that facilitate data transmission between field devices, PLCs, HMIs, OPC servers, and the historian. It ensures reliable and secure communication within the Scada system, often utilizing Ethernet-based protocols such as TCP/IP or industrial protocols like Modbus and Profibus. By integrating these components, a factory-centered Scada architecture provides comprehensive monitoring, control, and data acquisition capabilities, enabling efficient and reliable operation of industrial processes. But what about Scada? Well, Scada's system consists of software and hardware role is overseeing everything. It gathers data from PLCs and displays it in an easy-to-understand way on screens called HMIs, human-machine interfaces. With Scada, operators can monitor processes, analyze trends, and even receive alarms for abnormal conditions. Now, let's talk about how Scada is implemented in remote setup. In remote Scada implementation, the focus shifts from centralized factory setups to distant locations like oil wells, pipelines, or even weather stations. These sites often lack direct human supervision and require robust monitoring and control systems. Imagine a scenario where you have oil wells spread across vast, remote areas. Each well needs to be monitored for various parameters like temperature, pressure, and